Hi. Uh, See, state Ohm's law and explain the factors on which the resistance of a conductor depends. Okay. See, here is the statement of Ohm's law. So, what is the statement? The current in a metallic conductor is directly proportional to the potential difference applied across its ends, and provided the temperature and other physical conditions of the conductor are kept constant. See, we have one conductor here, okay, which is having some length and which is having some area. So if I apply the potential difference, if I am applying potential difference means connecting to a cell or battery, you can say it's a positive terminal and it is negative terminal. So now I am applying some potential, potential across its terminals. See, in this case, see the current flowing through it is I and the unquote, right? Now, according to this statement, so the current flowing through a conductor, that is I, is directly proportional to the current in a metallic conductor is directly proportional to the potential difference applied across its ends, and I have applied V be the potential difference applied across its ends. See, this is the statement, and if I erase this, or if I want to remove this proportionality sign, and if I put equality sign, then you have to introduce one constant that is proportionality constant. Here I am introducing the proportionality constant as 1 by R. So, and if you cross multiply this R, so you will get V is equal to I into R. So this is one of the important formulas. So very important. V is equal to IR. What is what? V is the potential difference, I be the conductor, and R is the resistance of the conductor. Now let's talk about what do you mean by resistance. And before going to that topic, so here they have given one lines, that is one line they have given. What is that? Provided the temperature and other physical conditions of the conductor are kept constant. What do you mean by other physical conditions? Other physical conditions means it may be its length, or it may be its area, size, shape, whatever it may be. So, and temperature. See, if you change these things, resistance will change. If resistance changes, automatically potential and current also changes. I mean current changes. That is why, so they have used these terms, that is temperature and other physical conditions of the conductor are kept constant. Got it? Now the resistance. What do you mean by resistance? Resistance means it is the effective opposition offered by the conductor itself to the flow of electric current. Actually, see here, when electron is moving in this conductor, it will undergo many collisions, right, between the electrons or atoms or ions, whatever it may be. So they will oppose this movement of electrons. See, if the current is moving in this direction, and electron will be moving in this direction, correct? So for this opposition increases with increase in temperature, as you all know that is why. So temperature should be kept constant. And the second question is the factors on which the resistance of a conductor depends. See, if I take a conductor, now I have taken a conductor of length L1. Now I will take another conductor having same area but the length is L2. Now the resistance of a conductor depends on what factors? Antaga, the resistance depends on its length. How? Resistance is directly proportional to length. If length increases, resistance also increases. If length decreases, resistance also decreases. That is why it is directly proportional to length. So if the length area is constant, length is changing, means then resistance also changes. Length increases, more collisions occurs, more resistance. That is why resistance is directly proportional to length. And what about area? So now I will use the same length of the conductors, length of the two conductors are equal, but area is different. Now the second one will be having some more area compared to this one. Now it will be having area A1. Now the second conductor is having the area A2. See, the resistance in first conductor is less compared to this thing. Means, the resistance is inversely proportional to area. More is the area, lesser will be the resistance. If the area is less, then resistance will be more. As you all know that if you have enough space, then resistance will be automatically, it will be less. That is why. So resistance is inversely proportional to area. ಏರಿಯಾ ಜಾಸ್ತಿ ಇದ್ದರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಏರಿಯಾ ಕಡಿಮೆ ಇದ್ದರೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ದಟ್ ಈಸ್ ವೈ ರೆಸಿಸ್ಟೆನ್ಸ್ ಈಸ್ directly proportional to length and it is inversely proportional to area. So it depends on first point. So resistance depends on length of the conductor, and the second one is it depends on the area of the conductor, and there are two more factors. It depends on the temperature. I already ಹೇಳಿದ್ದೀನಿ. So it depends on the temperature. More is the temperature, resistance also increases. More will be the resistance. Got it? The last one is it depends on the nature of the material. It depends on the nature of material. So these are the four factors on which the resistance depends: length of the conductor, area of the conductor, temperature, and nature of the conductor or nature of the metal of the conductor. So this is the statement and on which the resistance of a conductor depends. On these four factors, the resistance depends. Thank you.